Hey everybody, welcome to another video. For many of you, I guess this will probably be for hopefully many, because hopefully many people will see this. But for any of you who haven't seen my videos before, welcome. For everybody, welcome. This video is not officially, well, I am labeling it an Emacs video. I'm putting it on my Emacs playlist, but it's really an Advent of Code video. And actually, this is a triple threat video. I've been making posts over the last few years. I've done Advent of Code, and you can see, I've got, or you can't see yet, but now you can see, let's go to this one here. Now you can see we got Advent of Code here, this website, and it's this month-long, Eric Wassel puts it together. I don't know the pronunciation, I apologize if I'm getting it wrong, but Eric puts this together. Basically, it's a month-long event with a bunch of programming things in it, problems in it, and in past years, so for example, last year's, and you can still get these problems, we can go all these problems, or 2016, I don't know, whatever, it's a bunch of problems. It's an Advent calendar for coding problems, and each day another one is released. And I've been writing up posts in my blog of a teacher's point of view. So I talk a little bit about possible solutions, a little bit about how a teacher would look at this, maybe how a teacher might teach this, how a student, it's different for everyone, but it's a teacher's point of view, as opposed to just here's a walkthrough. And I thought I would do a video on this, and the triple threat is that, one, we're going to talk about today's Advent of Code problem, and you can see I've already finished it because I got stars here. But we're also going to do this in Clojure. I've been writing these in Clojure, and if you're a teacher, you may not have used Clojure, probably haven't used it for teaching. Most teachers, at least in the K-12 side, will have used, like in the high schools, they'll have used Python or Java, and JavaScript, maybe a few people using C or C++, but not so many using Clojure, which is a Lisp, and it'll be an interesting, it might be interesting for you to see how Lisp looks different, or how Clojure looks different, and how maybe it makes you think about problems a little differently. And also I'll be using Emacs, my tool of choice. So this is also going to be kind of a demo of my Emacs workflow in Clojure. And I'm not a Clojure expert by any means. I'm a hobbyist in Clojure. I mess around with it. I might do some things here that are idiomatically 100% wrong in Clojure. So if you're a Clojure programmer out there, feel free to, please let me know if I'm totally off base on some of the ways I'm doing things in terms of the right Clojure way. Just be nice about it, okay? So let's jump in. Now, the reason I've done these already is, and I feel kind of embarrassed, is I made this video before, but I kind of messed up the way I was using Open Broadcast System, and so it chopped off like a little bit of my Emacs window, and it just made it unfortunately not viewable. Like you could read it, but if you didn't know Clojure, which most viewers probably won't, you're not going to, like it won't make much sense, so I kind of have to make it again. But anyway, here's the problem. Little toboggan travel problem. The idea is we're trying to travel through this forest, all right, through these trees here, and we get this grid over here, and so we can see here the dots, and this is your input, and I've already copied this over onto my machine. This is not the real input, it's the sample input. And so you start here at this first location, which once we load into the computer is going to be 0, 0. And if you read down on the problem, you move down basically by jumping down using a certain slope. I think the word they used, slope. In this case, 3 right, down 1. And so you start here at 0, 0, and then you move to 3 right, 1, 2, 3, down 1. So those are both dots, those are both spaces. But then you go 3 right again and down 1, and now we're at a tree. And then you go 3 right and down 1, and you're at a space. But then you say, well, what happens next? I go 3 right, I'm going to be off the grid. Well, that's where the next part here, it says, because of the way these arboreal genetics work and biome stability, basically this whole grid is copied over and over and over. So right after this spot here is going to be another spot, which is a space, because it's kind of like it's a duplicate, then another space, then 2 trees, then a bunch of spaces. And it happens again and again and again and again. So as you go down, you just kind of go into these replicated versions. And what the problem is you have to figure out how many trees you cross over when getting here, and again, remember you're jumping, so it doesn't matter that you graze a tree slightly based on your, like a smooth travel. It's jump, 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 jump. So let's talk about approaching this. Now, if a student's approaching this, particularly if they're programming, if they've programmed in, I'd say probably in Java more than anything else because of, or C, but maybe not so much in Python. But you think of the first thing is like, let's read this into a two-dimensional array. And well, it's 11, this is 11 by 11. And so, gee, I only have to go 11 times. I can just copy over, instead of making it 11 by 11, I can just make it like 11, like much wider and make copies going over, and then I can literally just go through the entire array. And that's pretty easy, conceptually, but it gets a little messy and you have to kind of make the bigger array and copy everything over into it. But that's certainly like a beginner approach. You might not do that in Python because Python, you don't really use two-dimensional arrays as much. But you might. Another approach you might use is you might think about, well, every time I cross over to 12, it's 11 wide. This happens to be 11 wide, so it's 0 through 10. And when I get to the 11th one, I can subtract 11 and then continue. And then when I get to the end, subtract 11 again and then continue and then subtract 11 again. So I could kind of do this in a big loop and have an if statement. And whenever I get to that point, I can subtract. And that's also kind of a brute forcey way that I might expect a beginner to do this in. But really, the way to do this is this is the mod squad. This is all about the mod. It's modulo arithmetic. So one way of looking at this is you're going through each of these lines and you're traveling across. When you travel off of one end, you come back onto the other side. So you're going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or sorry, 0, 1, 2, 3, 4, 5, 7, 9, 10, back to 0, up to 10, back to 0. That's mod arithmetic. So if you just say, well, I'm going to be somewhere on this line, and you figure out using a mod, that'll put you in its place. And then you're on this line, and then you figure out where you are with a mod, and then this one. And so that's the way I started thinking about this problem, as this is really an issue of I'm going to be on some line, and that line is going to tell me some modulo pattern, some pattern here. Like in this case, this is the pattern. But when I'm on this line, this is the pattern. And then I'm going to be at some x value. And that x value, that column value might be 0, might be 3, might be 10, might be 2,436 if it goes far enough. But I know that if I use mod, it's going to keep wrapping it around within this range, and that'll tell me where I am. So that's how I thought about this problem. And then I also had to think about, well, how am I going to process it overall? And there were two ways of thinking about processing this overall that I came up with. One way, not the way I did it because I thought of this afterwards, is I could kind of do a simulation where I could pretend that I am the person traveling and I'm at an XY coordinate, and then kind of keep updating that moving through the forest. I thought about it a little bit differently, and I'm not saying my way is better. My way is probably worse, but I kind of liked it. Is I thought about, well, I'm actually going to be hitting a subset of points in the forest. So why don't I pull out the subset of points that I'm looking for, and then see which ones are trees and which ones aren't. So I'm just going to hit those candidate targets. So that's my overall strategy for this, my overall approach. And so why don't we hop over into Emacs and take a look at this. So I've already written this, but let's do it again anyway, because I think it's more educational, especially since I'm hoping that some people will be doing seeing this for the first time, the Clojure for the first time. So I'm going to call this demo day 3.clj. And so now I'm in Emacs. And in Emacs, the mode that I use for Clojure is Cider, and Cider is really really awesome. The guy who wrote it, he goes by Bug. You can look him up on look up Cider and look him up. He's got some interesting talks up there. it's the best environment that I've ever used for any programming language. I'm just going to change demo day, just change into this namespace because that way, it's kind of like if you're in a different module in Python, you won't have the variables, without specifying them. And this way I'm all in that one namespace. So anyway, but it's a really awesome environment, as you'll see. And so the first thing I want to do is I want to get my data. So what I'm going to do is I'm going to use this thing IO resource. You'll notice that it automatically put up my dependency. This is something from another Emacs package, CLJ Refactor, which I just installed yesterday and I'm just starting to learn about. And what this actually does is this just converts this into some resource object and it deals with the paths based on my project, so don't worry about it. But what I can do is I can slurp this. Now let me just actually show something before I do anything of this. Clojure is a Lisp, so it's a functional language. So in a language like Python, let's just say I have hello.py. In Python, I might go 2 plus 3, and that's going to calculate 2 plus 3. In Clojure, I would say plus 2, 3. And I can evaluate that up here. Let me go back to my REPL. Or, of course, I can evaluate things in my REPL on the bottom. So that's the form. So this here means this is one function, get its result, and the second function is slurp. And if I run that, I see this reads and it slurps it in. It reads my whole data in as a single item. Now, if you have too many functions within functions, it gets a little ugly. So Clojure has this thing called threading macros. So what it can do is this says do one thing and pass it to the next and pass it to the next. And again, if you're new to Clojure, this is just to give you a flavor. This is not a Clojure tutorial. Maybe someday after I retire or something, I mean, I'll be old enough in a couple of years, I'll make a whole bunch of Clojure videos or whatever. But for now, this is the flavor, and there's other good stuff out there. So I'm going to say do that and then slurp it. Take its output and slurp it. Same thing. And then what I can do is I can put it into a split line routine, which will split this into a list with each one being a line. And I should save that. I can define that as, let's call that our data. And I'm just going to use structured editing, which means I can just hit one key and it pulls everything into the parentheses. And now I've got my data. I've evaluated this. I'm using just Emacs keystrokes. And I can even inspect this and see it's now a list. And I'll go to the REPL to do this. I could say I can look at data. I can look at the first item in data. I can look at the second item in data. I can give me the nth. And a ninth thing here is I type in the nth and I get my completions. But then when I look on the bottom, it says get the nth, give it a collection and an index, and then what to return if not found. And so I'm going to give it the collection of data, and I want to get the fourth item there, and that's what it is. So these are the niceties of this environment. So I've got my data. The next thing I want to do is I want to build my candidates. I want to see the places where I can, that I can possibly go. And I know I have a slope right now of 3, 1. So what I'm going to do is I can use a little Lisp comprehension, which in Clojure is written as a for. So at a very simple level, I can say for R in range rows, and I'll just, and then what I'll evaluate to is just R, just to show it. And actually, I don't know what rows are. So we'll just temporarily, we'll say rows is the count of data. That's how many lines are in my list there. Execute that. And that's just, boom, that goes across. And then what I'm going to evaluate, and so that's the same as R for R in range rows in Python. So at this point, I know that my calculations, it's going to be row column. So the row is going to be R. So I'm going to put this into a little list, which is just like Python. The only thing is that the comma here is optional. So for example, here I can type 1, 2, 3, but I can also just type 1, 2, 3 with white space. And then the other side is going to be the multiplication of the row times my delta x, which is 3. So if I run here, I can see that this is going to give me 0, 0, 1, 3, 2, 6, 3, 9. And those are exactly the squares that I want to check coming down here. 0, 0, 1, row 1, column 3, 0, 1, 2, 3, 2, 4, 5, 6. That's looking good. And I want to put these into a variable, and let's actually write this into a function. So let's write a function called build def n. So this is how we declare a function in Clojure. Build candidates. And we're going to pass into build candidates data, and we're also going to pass it a dx and a dy. And I'll explain what that and I'll slurp that all in. I'll explain what this double things is, but this double bracket thing is. But you can just think of this as 2 parameters data, which is going to be this guy here, and this is going to be the dx and dy, and I'm putting it in square brackets for a reason. And now I have to know what my rows are, because I don't want to declare this as a global. So what I'm going to do here is, if I were in a language like Python, I might do something like this. I might say diff build candidates, and then there'll be data, row dx and dy. And then I would just say something like rows equals the length of data. Now, in Python, you can put your variables anywhere, and it's kind of hard to keep track of the scoping and whatever. And that's true for most languages like Python, Java, etc. In Clojure, you use let forms, and you say, so everything between that open paren and the close, we can have some declarations. And we're going to say, for our declaration, that the number of rows is going to be the count of data. It's going to be how many rows are counted in data. And let's slurp that all in. So this becomes numRows. And now we've built our function. So we're going to build candidates. And we're going to build candidates with data. And our slope is going to be 3, 1. And there we have it. Everything looks good. And notice that I put in 3, 1 as a list here. So this is what's known as destructuring. What it did is it pulled it out. So I didn't have to do a separate assignment afterwards. Like in Python, if I had slope up here, I'd have to say like dx equals slope sub 0 and dy equals slope sub 1. So that's kind of a nice feature here. But now I can build my candidates really easily. So let's just for the time being say candidates, and we'll define candidates to be build candidates from data with 3, 1, just so we have it to play with. And we can inspect that just to see it's indeed what we want. So I know that now I have all the candidates that I have to check. I have to be able to check them. And so to do that, what I want to do is I want to be able to look into my data and see if a particular cell is a wall or if it is a tree, not a wall, if it is a tree or if it's a space. I say wall because whenever I make mazes, I use like the hash and the dots as well. So let's write another routine to test a candidate. And to test a candidate, we'll once again pass in the data. And in this time, we're not going to pass a dx and a dy, but a row and a column that we want to test. All right, so we want to see what the cell is at that row column. And I mean, I know this is I know I'm mixing rows and columns and X, Ys, and it's probably not a good idea, but we'll see how I can do on this. So now we're going to make some local variables. So we'll use a let form. We're going to say the number of rows, once again, is count the data. Count the data. And we're also going to grab the number of columns, which is going to be count the first data. So that'll be it for there. And again, that's like in Python, if we have a string of strings, or like if we have a list where we have like, L equals hello, if they're all, just whatever. If I say the length of L will give me the 2, but if I say the length of L sub 0, it'll give me how wide it is, because it's the length of that 0, 1. So that's going to be my number of columns. Now what I also want to do is, now here's where that mod comes in. Number of the columns is going to keep going over. If you see down here, it goes way past 11. So actually the column I want to test, so we'll just call this the test column, is very simply going to be, we're just going to mod the column that we pass in the test with the number of columns. That's going to cause it to wrap around. So now we've got that. Now we just got to find, we now have to go to the row and the column and check it out. So let's pull out the row. So let's get out the row string. And that's going to very simply be, give me the nth from the row, the nth item from data, and given the row. So this row is going to be 0, 1, 2, 3, whatever it is, the parameter. And then we're going to want to pull out the character, which will just be the test column from that. And then we're just going to return the character. And we got a mistake in here. This is defining a function, not a variable, so it's def n. So now we can, let's go into here and let's test candidate. Let's do a couple of tests on this. Test candidate of our data 0, 0. That's a space. 1, 3. That's a space. 2, 6. And that's a wall. So this isn't really testing it in the sense of true false. It could, but for now we'll just leave it this way. So now this is kind of cool in that I can test a particular candidate to see if there's a wall there. I keep saying wall, a tree there. And I have my list of candidates. So now I can do this for each of, for every candidate. For every candidate, let's figure out what's there. And then I can see, count how many of them are trees. Now, I could do this in Python. I would probably, I might use a list comprehension, or something like that. I might do something like in Python, say, give me X, or rather test candidate X for X in candidates, and that'll pull everything out. And we could do something like that with a list comprehension in Clojure. This for loop is a list comprehension in Clojure. That's how we do it. But instead, we usually use map, and map says map a function over a data set. So it says basically apply this function. So we could write a function. Well, we have a function called test candidate, but test candidate takes 2 variables. So what we can do is in Clojure, we can write, we can do something called partial. What partial does, let's say we have a function, and we'll call it add, and it takes 2 parameters, a and b, and it just returns a plus b. So we can say add 3 and 4. What we can do is we can define, we'll call it f, and we're going to define this to be the function add, but we're going to fill in 30 for our first parameter. Whoops. So now if we say f of 5, it's 35 because it just puts in the 1 for b. Now there are other ways of doing this in Clojure. We could also use an anonymous function, but we'll use the partial for now. So we're going to say map onto the function that we result from partial on test candidate are candidates. And I have to give it the first candidate. And so notice that now that's giving me the cells. But what I want to do on this is I want to filter this. And what filter lets me do is like the if statement. And so for the if statement in a list comprehension. And so this will accept an anonymous function. And I do that in Clojure like this. This is an anonymous function with 1 parameter. and the parameters with a percent. So if I want to say, like, let's make an anonymous function, so a function with no name. So I can define, let's redefine f to be an anonymous function. I'm hitting wrong keys and looking down because this is a brand new keyboard that I just got. I just set it up like a couple hours ago. So an anonymous function will say plus the parameter to 100. And so if I say now f of 5, but I've never named that function. I can just put it as a throwaway. So I'm going to say I want to test if the parameter that the thing we're putting in, which is going to be, it's going to in turn do each one from the map. And actually, let me show an example of it down here. Let's filter greater than 5%, you can put the, or rather greater than %5, and then let's give it a list. And you'll see here, it only keeps the one that are greater than 5 in that case. So we're going to say if it's equal to the tree, and let's slurp that, and those are our trees, and then we can just we can just count them, and we have 7, which happens to be the right answer for part 1. Now, what's cool, let me try this. I don't know if this will work or not. I just installed this CLJ refactor, and this starts to get looking a little ugly. So at some point, you want to convert this form here into this threading macro type form. And so let's see if this works. So let's see. Let's see if I can do this. Yeah. Now, okay, I don't remember so we'll do it manually. Again, I just installed the package, and I'm not going to take the time to look it up now, while you're all watching. So we're going to say, again, a threading macro. We're going to take the candidates. So let's see if we just evaluate that. Those are just my candidates. Now I want to and in fact, we don't even have to do that. We can actually build our candidates. Build candidates, and build candidates takes my data and my 3.1. So that's that. So I've now built my candidates. And now after I build my candidates, I can now map partial test candidate data. And that pulls it out to there. And then I can pass this through my filter. Pulls out to there, and then the count. And so that's just a much more elegant way of writing it. And so I can just define, define function part 1 on a data set. Well, actually, let's even say part 1 on a data set with some slope, and then that's our slope. And so we can just come down here and say part 1 on data with 3.1. And we get our 7. And to check this, we can now change this over to day 3 data, reevaluate that, and we get 169, which is indeed the answer we should get. So that's all good. So again, I hope you're seeing that this environment is really cool, but also there's this elegance to the language. So now we're up to part 2. And part 2 throws a little bit of a loop. And the loop is, well, now we've got to do it for multiple slopes and then multiply them together. And that means we're going to have to change our candidates, because with our candidates, now it's not going to be every row. In fact, it's going to be times row dy, and this should be dx. So now if I build candidates, let me reevaluate this to make sure that it's just a small data set. That looks not okay because I messed it up. That looks okay. That looks pretty much the same. But if I now make my dx2, I'm going way too far. Now, I'm just going to take the lazy approach. And for my lazy approach, I'm just going to say when space there. I'm going to only calculate this when r times dy is less than rows. So now it'll stop when it gets, it gets that last row. So that's just kind of, that should work now. So now the next thing we're going to do is if we look over here, it says that if I give it a slope of 1, 1, or let me use a slope of 1, 2, it should give me 2 trees. So let's see if I do part 1 on data with a slope of 2, 2. And, oh, sorry. The slope is 1, 2. And that's not right because again, new keyboard, 1, 2, 2 trees. So it looks like it's handling that slope of 2. But now I've got to do it for a bunch of slopes. So let's define our slopes. And my slopes are going to be 1, 1. And again, I could put in commas, but in Clojure you normally don't. And so now I can just map. Well, I want to do part 1, but I only have the 2 parameters, so I'm going to use partial again. And we're going to send in data as its partial. And we're going to now just have to send in its slope, and that's what map does. It'll do it for each slope. And now I get 2, 7, 3, 4, 2. That's exactly what I want. And I can just use reduce on this. And 336, which is what it says. What reduce does, it says apply this function. So I'll just do plus here. And what it says is do plus on the 10 and the 5, or the 5 and the 10, and then to that plus 15, and then it can go on forever, however many you have. And in this case, we're going to do multiplies, which is what it says to do. And so we kind of have our answer, but here we'll try it for the real data set. Day 03. And that's not right. I got day 03. Let's see. No, data looks reasonable here. So we got a little bit of a mistake somewhere in here. I may have hard-coded something in here. So data now should be everything. That doesn't look... I shouldn't be using that at all. Do I hard-code anything in there? I don't think so. I don't think I hard-code something in there. Let's get rid of the reduce for now. One, 1, 3, 1, 5, 1, 7, 1, 1, 2. That is correct. Perhaps my width. Build candidates data. And that looks reasonable. Let me make sure I've got the right thing over here. Num rows is count the data. Right, it got the 7 correct, which is what it should be. That should be this one over here. What am I missing? What am I missing? Let's see. And something is wrong with that. Maybe, actually, I'm not sure. I could check, because I have written this before, so I still do have a working version of this. So I'm just going to stop the video for a second, because there's no real reason for you to watch me struggling through this, but I'm going to resume it as soon as I see what stupidity I am missing. Okay, so I'm feeling pretty stupid here. I just see what my problem is. You'll notice that this is num rows, the number of rows in question, where I had rows here. Now, rows was still defined from that global variable way back, and I didn't fix it, but now we are good, or now we should be good. So now, and I put this test in for part 1, we're good. That should work. So my slopes are now looking much better, and now I can reduce this, and that's my answer. And of course, I could use this construct again, which I like, which is we'll first map those part 1s, and then we will do the reduce. So that's the complete solution, and that's all good. So I felt a little dopey there for a minute, but okay, it looks like we fixed it. But I'm hoping you appreciate some of the elegance that Clojure can have once you get used to it. I know it looks weird until you get used to it, and I'm hoping that you appreciate some of the beauty of Cider as an interface as well, and advent of code. And I don't know if I'm going to make any more videos like this or not. I don't know if people find them useful or not. I mean, if you made it to the end, let me know. Yeah, but hopefully, if I have time, I'll continue to do advent of code, and maybe I'll write up 1 or 2 more of them. And yeah, and so that's it. I hope you enjoy.